Today we're going to be talking about web components and PWAs. We're going to be doing a lot of live coding, hopefully be a lot of fun. This is me. My name is Marcus. I work as a lead developer advocate. I'm focusing on kind of modern web technologies, web, everything that's kind of new and exciting. I work for a company called Vaadin. How many of you have been to our booth downstairs already? Okay, almost half. To the other half, welcome down. We have some Vaadin t-shirts like this. We'd love to give you some. Vaadin is an open source company. We build stuff for the web to make it easier for developers to build really awesome stuff. Vaadin itself is a Finnish word for reindeer, so that's where the t-shirts come from, and that's where the logo comes from, if you're wondering. But today I want to talk to you about two of the kind of new exciting things happening on the web. I'm actually doing 2 talks at Code One this year, and they're in the reverse order. So if you come to my talk tomorrow, I'll tell you why I'm excited about these technologies. But today I'll just tell you about them. So the first thing I'll talk about is web components. This is a platform standard way for us to define reusable user interface components on the web. How many of you are familiar with web components from before? Okay, that's almost half of you. That's actually pretty good. How many have you used them or built them? Okay, so that's like 5.5 people. Good. So essentially, the problem they're solving is that when we're building big applications, it's usually easier for us to split those complex applications into more manageable pieces. We do that by kind of extracting out common functionalities into reusable components. That way, it's much easier for us to reason about our application when we're able to build it out of these bigger building blocks. It's also a lot faster than building things from just divs and spans and things like that. Now, this is something that you haven't really been able to do on the web platform itself before, and it's something that the community of developer has kind of noticed over the years. So there have been countless different tries of fixing this problem in the past. So I'm sure everyone here who has done web development has used something like jQuery UI or maybe YUI or Dojo. More recently, you might have used something like React or Angular, maybe Vue. These all come with their own ways of defining reusable components and kind of solving this problem. The problem with all of these approaches, though, is that because they're not supported by the browser directly, it means that the browser needs to kind of emulate these components. It means essentially that they're going to be turned into a whole bunch of divs and spans in JavaScript in the end. And emulating these components in JavaScript is not necessarily the easiest thing to do or the most efficient thing to do. So fortunately, recently the web platform has kind of caught up and provided us with a platform standard way of defining components that can be reused not only in one framework, but anywhere HTML works. So you can use them on a plain HTML page. You can use them in Vue, React, anywhere. The way this works is that we essentially just define new HTML tags, and after you import them, you can just write them in your HTML, and your browser will actually run them exactly the same way you defined them. So if you write a Vaadin date picker, you get a Vaadin date picker. So that's a really powerful new tool in our toolbox as developers. Now we're actually able to build components that we know we can reuse throughout our applications, no matter what those applications are written in. The second thing we're going to talk about are progressive web applications. How many of you are familiar with progressive web applications? Okay, that's again about half of you. So progressive web applications, if you're not familiar, are essentially web applications that progressively become better and better, kind of more like native applications as you interact with them. So if we just take an example here of us interacting with a progressive web application to get an idea of what they could provide us. So on first load, when we come into a progressive web application, it will be like any other web application. We're in our browser, we found a link to it, we opened it up, we started using it. In the background, though, something special is happening. So it's registering something called a service worker, which will start caching all kinds of stuff and making sure that we're able to enhance the functionality the next time a person comes into this application. So if this is an application that we continue to interact with, we come back to it the next day, the browser itself will offer us an option to install this application. So Unlike with native applications where we need to first go into an app store, find an app, install it, and then check if it's something that we want to use, progressive web applications actually let us use the application first, and then if we continue to use it and find it useful, then we can opt into installing it. So it's kind of letting us try the application before we commit to buying it. And for many kind of more infrequent use applications, single use applications, there might not even be a reason for somebody to install the application, but that's not a reason for us to not give them the full experience. So if we decide to install this application, it'll get installed on our device like any other application. It'll be in our task switcher. If we launch it from our icon, we are able to open it up as a full kind of full-size application. It hides all the browser Chrome and everything, so as far as the user is concerned, it looks like a native application. It behaves like a native application. It's able to receive push notifications. It can work offline. So essentially, as far as a user is concerned, it's indistinguishable from a native application. Just that we've written it using web technologies. We don't need to write separate applications for different mobile platforms. So it's a pretty nifty way for us to actually give really nice user experiences to our users without having to actually build native applications for a bunch of different platforms. So this will be a fairly hands-on presentation. I'm myself a very hands-on kind of learner. I like to do things or see somebody show like how things actually work in code for me to understand what they do. So instead of me showing you a lot of diagrams and kind of pseudocode of how this works, we're actually going to build an application using web components, and then we're going to take that application and turn it into a progressive web application, hopefully. So I'm going to do all of this in just plain vanilla JavaScript without any frameworks or libraries, just so we can focus on really what the browser itself provides us. We're going to come back at the end of the presentation and look at some tools that we can use to kind of simplify this process, but I think it's really helpful to just understand what we can get from the browser just out of the box. I will be sharing the link to the code after this, so you don't need to take a lot of notes if you don't want to. Just try to understand more the general flow of things, what I'm doing, and just understand the concepts. Okay? So let's get coding. Before we do that, though, I want to warn you that we are going to build a newsreader. So if you've like opted out of reality, and that's a kind of understandable thing to do in 2018, just like cover your eyes at the right moments. All right, so we'll jump into the code here. Let's see. How's the font size for you in the back? Are you okay with it? All right, good. So I'll open up a browser. Let's do a demo window here. Okay, so the application I have a very small kind of stub that we're starting from. We have an index file here that just has a header section with a header tag. We're loading an index file. We're loading a style sheet, and that's pretty much what we have. The index file itself is completely empty, and I've extracted an API address into a separate JavaScript module so that I don't have to type out the whole URL during the demo. So let's start by first building the application itself, and once we have a working, just plain web application, then we're going to take and turn that into a progressive web application, walking through the different steps that we need. So the first thing I want to do in any application that's using JavaScript is add a event listener on the window object for load. So typically when we're kind of enhancing an application in JavaScript, we want to make sure that we let the browser render everything first. That way the user gets a really nice experience. Even if the fetching the actual news might take a couple hundred milliseconds, they already get something very quickly. So once the window has loaded, we'll fetch news. And this is, no, that's not what I wanted to do. This will be an async function. Everyone here familiar with an async function? So async functions are essentially just a more human-readable way of dealing with promises and asynchronous coding. So instead of having to have these long chains of then, we can just have some code that looks more like imperative code, but it actually doesn't block. The first thing we want to do is get a result from calling the API. So we'll do a fetch. The URL, like I mentioned, I have in this other file, so I'll just do an import for that. And this is just a normal JavaScript ES module import from newsapi.js. Here I'm not even using any like Webpack or any other bundler, so I need to specify the actual JavaScript file name here so the browser is able to load this. Here we're going to get the top headlines URL export, and that's the URL that we want to fetch. And that will give us the result itself. From that result, when that comes in, we want to get the JSON value. So we want to convert it to JSON. Again, that's an asynchronous operation, so we will wait for it to complete. And with that, we'll have the actual JSON. Now what I want to do is, this JSON will contain an array of the different news articles. And for each of those articles, I want to create one new web component, a news article component, and we're going to put them all into this main section of our web page. So I will do a document query selector for the main section. That's where we want to put things. Let's extract that to a constant. Let's call it main. And then what we do is we take the array of articles that we have in the JSON, equals dot for each. So we just go through all the articles, and for each of them, we'll create a new component. So here I'll just do it imperatively. Again, like we're not using any framework that would do this for us, so we're just going to do an element which will be document dot create element, and the tag name that we will be creating is news article. Once we've created the element, we're going to pass it in the actual JavaScript object for the article, so we can pull in all the headline and the image information and everything. So we'll create a little API for our component. So we'll do just element.article equals this article from our for each. Finally, we're just going to take the main area, the main tag, and we'll append a child to it, which will be this element. Okay, so that's a lot of coding without checking if it's actually running. So what we'll do here is open up the console, type in serve, so just a plain HTTP server. This will kick up a server on port 5000, I think. Yep. So we'll go to localhost 5000. And we can see that we have the h1 tag here. If we open up our dev tools, we should be able to inspect a little bit what's happening in the browser. So let's open up the main. Is that big enough? Yep. So you can see that we have these news article tags here that we created. Now, of course, a news article isn't something that HTML ships with out of the box. The browser doesn't know what we're talking about when we're talking about a news article. It does diligently put them in there for us, like in case it would happen to work, but it doesn't, obviously. So in order for that to actually work, we need to create a definition for this new tag. And this is fairly straightforward. What we need to do is create a new file for it. I usually like to call it the tag name.js, so newsarticle.js. And the actual creation of a new HTML tag is in two parts. First, we need a implementation for it, and then we're going to register that implementation into a registry. The implementation looks something like this. So we have a class, news article, that will extend from the base class HTML element. The second part is using this registry called custom elements, and it has a define method on it. The define method takes in a tag name. In our case, that's the news article. That's the tag name we wanted to use. And then maps that to a implementation, which is our news article class just above. If you remember, the only piece of API that we created for this element is just that setting of an article. So we'll create a setter for article takes in the article itself. And what we do here is just say this.inner HTML equals a template string where I'm pulling in the URL, the title, the image, and the description if they're there. So this, in like its most simplest form, is how you create a new HTML tag. Now, the only kind of missing piece here is that we need to import this. So it actually gets loaded. So we'll just do an import, and then we just import this news article file here, JS. All right. Let's go back to our browser, cross our fingers, hit refresh, and it works. So now if we look at these news articles, you can see that they actually have this inner HTML that we defined for them. They look pretty okay as far as news can look these days. So that's how you create an HTML tag if you wanted to do that. Now, a lot of times when we're talking about web components, you will hear people mentioning Shadow DOM. Shadow DOM is another part of this technology that allows us to encapsulate the inner workings of this component, basically just bundle up everything this component needs to work into one reusable package that we can use wherever without risking it breaking the styles of our main document or the main document breaking the styles of our component. So let's see how we can use that to our advantage here. So we'll go back into our article here, and we'll create a constructor for it. Constructor, we need to call super here, just let HTML element do its thing to get set up. And then we'll attach a shadow root. So we'll do this.root, just save it to a variable, and then call this.attach shadow. This will take in an options object where it has a mode property that should be open. There's an option for setting it to closed, which according to the Google documentation is always the wrong answer. So don't choose the wrong answer, just choose open. I don't know why it's in there. So then, in order to actually use this, instead of just setting the inner HTML of our component, we actually set the inner HTML of that shadow root. So if we save this, go back into our application, you'll see that while our news articles are still here, the styles broke completely. And this is because we have now encapsulated the implementation into this own sandboxed Shadow DOM. So in order for this to work, we will need to move over those CSS rules. Let's do CSS. So what I'll do is I'll actually just package all the CSS that was for this news article and just put it into the article itself. So I'll just create a style tag here. Style. We'll paste in the news here. That doesn't look very nice. And since we are inside the news article tag already, we don't need this extra selector here, so we can just go ahead and delete that. Every style name here is scoped into this component itself. We'll save this, refresh, we can see that, again, it works. So that way, now we have a single JavaScript file that contains the entire implementation of this. This is something we could give to our coworker in a different project, and they could just use it as is. We have an API for it, for setting the article. They don't need to know how it's implemented. It just works. So the question is, like, I could have done it without the Shadow DOM and embedded the styles in there, and it would have worked anyway. Correct. But the problem with doing that is that if I were to import that into another application that wasn't this application, it would have styles for H2, it would have styles for A and for image, and it would most certainly break any application that you would import this into. So it would be a very it would be back to the jQuery UI days where you import the CSS file and it just breaks everything else you have in the application. So that's why we want to use the Shadow DOM wherever possible. All right, so we've built our application. Right now, this is a plain old application. If we go offline, it doesn't work. There's nothing progressive about this. It's just a plain old web application that happens to use web components. So the next part that we want to do is turn this application into a progressive web application. I think one of the best ways of accomplishing this is using the application tab here in your Chrome DevTools. It will essentially walk us through the whole process one step at a time. So we'll start up here at the top on the manifest tab, and it will just tell us that there is no manifest. So that's the first part of turning an application into a progressive web application, is identifying it. We identify the application by creating this manifest file. So I'll create a web manifest.web file like this. It's a JSON file, and it collects just some basic metadata about your application, like what its name is, if it has a very long name, a shorter name that would fit underneath an icon, how it should be displayed when it's launched on a device. So standalone would mean that we hide the browser Chrome. We can define its icons and things like that. Once we have that file, we just need to link it from our HTML file. The linking is exactly the same as loading a style sheet, just that we're loading a manifest file instead. We save this, go back to our browser here. You'll see that it got picked up here, and it will actually allow us to try to add this to our home screen. So if you remember, with progressive web applications, that's one of the main things we can do. We can add it to our home screen. So we can try to add this to our home screen now, and it will tell us here that it's not able to install it because we do not have a service worker. So that's the second part, like big part of building a progressive web application, is having a service worker that will allow us to make sure that this application works reliably regardless of the network connection. Essentially, the service worker is a JavaScript worker that sits between your application and the network. So any network request that goes out from our application to the network will first go through this service worker. There we can decide what we want to do with it. In our case, we can just kind of return every static asset just directly from the cache. There's no need to go out to the network for those, so we get a super fast startup. For any of the news, we'll actually try to go out to the network and kind of save the result that comes in. And then if that fails, for whatever reason, we can always fall back on whatever result we had last. So we can just kind of continue to serve whatever the last piece of news that we had. All right, so we'll create a service worker file. It's just a normal JavaScript file. And the way we load this is, after we've loaded the application, we've fetched the news, kind of the user is already happily using our application. We can go in and register the service worker. This comes in kind of two steps. So as we register, looks something like this. So we do feature detection. We make sure that our browser actually supports service worker. If it does, we call navigator.serviceworker and register the file. And then we can catch it in case that fails for whatever reason. We can do something about it. In this demo, we won't. OK, so now we have a service worker file. We can go back into our browser and, again, try to add this to our home screen. And it still says that we can't install it because it doesn't work offline. How does it know that it doesn't work offline? It's probably because our service worker file is completely empty, so there's a very small chance of this actually doing anything useful for us. The service worker is entirely event-driven, so it only does things in response to events. The first event that a service worker gets when you register it is the install event. When a service worker gets installed, typically what we want to do is take all the stuff that we know won't change, all the static assets, the headers, the footers, the style sheets and stuff, and put that into a cache so we can use that on subsequent loads. The way we do that is by using the cache API. It's another fairly recent API. Essentially just, as the name implies, a cache that we can use for mapping between requests and the responses. So we'll give it a name, and we'll map a list of static assets there. So I'll give this cache name equals, let's see, news version 1. And then we'll have the static assets, which will just be our HTML, CSS, and JavaScript files. We'll save this, go back to our application, refresh here. Let's go in and check our cache storage here. What we're expecting to see is that all those static assets actually did get cached, and they are here. so that's looking good. Are we able to install it now? Does it work offline? How many think that it will work offline? Good job. You're definitely right. So it's still not able to work offline because we've just put things into the cache. We're never ever using anything that we've put into the cache. So we need to kind of convince the browser that we will actually provide the user with a good experience. So the way we do that is by listening for the fetch event. Now the fetch event is any network request that goes out from our application to the internet. They'll get intercepted here. In our case, I'm going to do a very kind of simple determination of how we're going to handle it. So if we're fetching from our own origin, basically our own website, let's assume it's a static asset that we've cached. If it's not, if it's from the network, from the news API, then we'll first go to the network, then cache the response, and then return it. So the cache first method looks something like this. Again, we open up our cache name here. We check if there's something that matches this request. So the request is the key in our map here. If there is something that matches, we'll get a response. If there's not, we can always defer to the network and see if we might be able to fetch it from there. The second is the network first approach. So here again, we open up the cache. And we start by trying to go out to the network. So we do a fetch the same way as we did before. And if that succeeds, so if at any point this fails, we'll just fall through to the cache. So we can assume that all of this works, or then we do this. If that works, we'll put a clone of it into our cache. That way we have a copy of that for later use if we happen to be offline at the next time we try to use the application. And then we'll just return the response. So that way we always keep getting the latest news whenever we're online, and then we can fall back by just giving back whatever the cache matches. All right, let's go back to our news here. One thing that you want to have checked here when you're doing development is this update on reload, because normally a service worker is very conservative. The way it works is it will load the next time a user comes in, it will go into that install phase, but it won't actually activate until the next time they come to the site. The idea being that we don't want to potentially swap out the running JavaScript midstream in a running application. That may or may not be what you want to do. So having this update on reload will make sure that anytime you reload the page, you actually force the browser to reload the service worker anyway. All right, so let's reload this. Let's go into our cache here. And we should be seeing all these other assets here that weren't there before. So if we go here, and how many of you think that we're able to add this to the home screen now? 2 people. All right, let's see. Yeah, I don't think that's got anything to do with it. Well, we should be able to add it to the home screen now. For whatever reason, this morning, we're not able to. We are, however, we're able to go offline. We're able to refresh the application and continue reading our news, even though we are offline. So that's how you take an application. You start by giving it a manifest file to identify this particular web page as an application to the browser. Then you need to go to the next step and provide a service worker to kind of convince the browser that this is an actual application that will handle offline situations. Now, how you handle an offline situation is very up to your specific application. Many even native applications don't really do a whole lot when they're offline. They'll just have a branded screen saying, like, your Twitter or your Facebook will just basically have the app shell there and just say that it can't load the latest tweets or updates because you're offline. So you don't actually necessarily need to include a lot of offline functionality, but this gives you a way of actually handling it gracefully, giving something a branded experience regardless of what the actual network connection is. All right, so let's jump back into our slides here. Where are we? Here. So if you're interested in poking around the code, you can find it up on my GitHub. I'll post both this link and screen recordings of the whole live coding thing that I did here on my Twitter. I don't know where else to put it because we don't have a way to kind of give those resources to anything but Twitter. So I'll give you my Twitter handle at the end of the thing again if you're interested in seeing that. So on to the even better news. So these are a lot of cool new technologies. What's even better is that they're something that we can pretty much start using today. They're not something that's in the utopian future. They're something that's already implemented mostly in all browsers. So progressive web applications enjoy support across all browsers in their latest stable versions. Web components have native support in Safari, Chrome, Firefox just shipped it yesterday. The Edge team announced about 3 weeks ago that they started coding it, so hopefully we'll get that in a release or two. For those browsers that do not have native support, there is a polyfill that can be loaded to give you support all the way back to IE11. So it's something that you can already kind of start playing around with. Sites like YouTube are already using web components, so they are kind of used in already pretty kind of big places. All right, so now that we've worked with the very low level like browser APIs for building these things, I think it's good for us to also take a look at what are the tools available to us to kind of make this a little bit smoother for us. Those APIs are by design very low level because they're built to enable library vendors, framework vendors to build any kind of implementations on top of them. So they were never really designed to be end user APIs. So if you want to build a web component, there are a ton of good libraries available for you to do that. For instance, the Google team has something called Polymer or Lit Element that we use, for instance, at Vaadin. The Ionic team has a library called Stencil, which takes a TypeScript file and compiles it to a web component. You can actually, as of latest Angular versions, you can take an Angular component and turn that into a web component. The nice thing is that you have like this whole variety of different ways of building a component, but the end result will be interoperable with any other way of building the component. So that's the beauty of having standards that we can all base on. For progressive web applications, you might already be building one even if without knowing. So if you're using kind of any of the larger front-end frameworks of today, their CLI tools are most likely already taking care of caching all those static assets for you. So they have build tools like Webpack or Rollup that will kind of inspect what files you have, what's static, and it will already cache those for you. If you're in an existing project that you would like to turn into a progressive web application, I highly recommend looking at the Workbox project by Google. It's essentially a service worker library that gives you all of these like cache first and network first and all kinds of strategies just as ready-made solutions that you can just map to regular expressions. So you can just say like, for this regular expression I want to do cache first, for this I want to cache like up to 30 images but expire them after 3 days, or cache up to 100 megs. So you can have a lot of kind of fine-grained control over what you actually want to cache and how long you want to cache it for. If you were to kind of do the similar implementation just using the low-level APIs, you would probably have thousands of lines in your service worker. So really look into using that. It's being used by over 80% of production PWAs today. For web components, one of the nice things about them being reusable across the board is that you don't necessarily need to build your own web components. Companies like us already have built really cool web component libraries. Our library is an Apache licensed open source library of these components that you can use wherever. You can use them either through the web component API that we've been working on today. We also offer for Java developers a server binding for them, which gives you a very high-level Java API with automated browser rendering, automated server-client communication. This is something that sounds interesting to you. We are down in booth 5407, so if you see a reindeer down there, just come on over. We'll get you hooked up with some t-shirts and stuff while you're there. If you go to our website, you'll find more information about all those components and how you can install them and how you can use them in your projects. All right, so I think we have a little bit of time for questions here, if you have any. Yes, sir? So if you only have edge. Yes. Okay. So the question is like, what if we're not entirely offline, but our network is really slow? Like in PWA circles, we call this lie-fi. It's like you're on Wi-Fi, but it's actually just a filthy lie. Nothing happens when you're on it. So in these situations, a library like Workbox will allow you to define like what's a timeout, like how long are you willing to wait for this particular thing to happen. If it takes longer than that, just like forget about it and just return something else. All right. So if you have any questions that you kind of come up with later on, you feel like you get a good question, just ping me on Twitter. Like I said, I'll post both the link to the code itself and to screencasts of both the coding parts, both the web components and the PWA, up on my Twitter after this. So with that, thanks for coming. I hope you learned something. Thanks.